Hi, and welcome to the Restorative Wellness Clinicians Corner, the video series exclusively for functional health professionals, where we interview the top experts in the latest research, products, tools, and best practices for getting your clients exceptional results. So welcome, everybody. I am super excited for today's guest for the RWS Clinicians Corner. We have Kiran Krishnan here today. And if you've been part of the RWS family for a while, you might have actually heard him speak. We were chatting before, I think it was like 2018 or 2019 when he came here and spoke to us originally. And we're super excited to have him back. He's going to be talking all about the latest research and the connection of our microbiome and the brain. In case you don't know him, Kiran is trained as a research microbiologist, and he left academic research to help bridge the translational gap between research and commercial innovation. He has held leadership roles in international health and wellness companies. He's also founded and scaled research and technology development companies, including, most recently, Microbiome Labs, the preeminent microbiome therapeutics company in the U.S. integrative medicine market, and one of our favorites, as you all know. Kiran has published numerous studies in peer-reviewed scientific journals and holds international patents in his name. He's a frequent lecturer and nutritional and medical conferences, and he is a sought-after expert on the human microbiome for health programs. He's currently the general manager of Novozymes One Health North America and is a science advisor to 5 other companies in the market. Kiran, welcome. We are so excited to have you here.
Thank you. Thank you so much for having me. And it was great to see you not that long ago in Portland. Nice to be able to do an in-person event, but I always value the opportunity to speak to lots of different people in different places at once. So thanks for having me here.
Yeah, thank you so much. Well, I'm going to turn it over to you.
Okay, very good. Let me share my screen. Great. Okay. Well, thank you so much for this opportunity, Martha, and I appreciate any chance I get to speak to healthcare professionals, because at the end of the day, you guys are on the front lines and you're fighting the good fight. You've got lots of people that depend on you, lots of people that are suffering and struggling and not gaining really relief the way they should be able to. And there's, hardly you could find a more significant topic on this when we talk about struggles than the gut-brain axis, because anxiety, depression are at epidemic levels. We know that cognitive decline is also at an epidemic level. We know that Alzheimer's and Parkinson's, the frequency of that is just going increasing over time. When you look at depression, I think somewhere around 21 million Americans suffer from depression, and over 40 million Americans suffer from anxiety alone. And the interesting thing is when you look at IBS, for example, right, irritable bowel syndrome, we now know that IBS is not a primary gut issue. It's actually a neurological issue. It's a gut-brain issue. And around 45 million people suffer from IBS, and about 55% of people that suffer from IBS have confirmed anxiety and or depression, right? Compare that to non-IBS sufferers, it's less than 19%. So you're almost 2.5 times more likely to have anxiety and depression if you have IBS. And that's because anxiety and depression are also a gut-brain issue. So it all kind of goes together when we start looking at the most prevailing conditions that your typical person walking down the street is suffering from. They're suffering from indigestion of some sort, right? Whether it's bloating, gas, food intolerances, chronic constipation, chronic diarrhea, all of the things that fit under irritable bowel syndrome, or it's anxiety to some degree, depression to some degree, attention deficit disorders, other kinds of mood disorders, certainly sleep disorders. All of these things are so prevalent, and you see such high frequency in our society. And many of these people aren't actually going out and seeking assistance, right? Many of them are self-medicating. If it's cognitive issues like anxiety and depression, they're using recreational drugs, or they're using food, or they're using other addictive dopaminergic behaviors to try to increase dopamine to feel better about things. Or if it's a gut issue, they're taking their Metamucils, they're taking, every kind of over-the-counter thing they can find at the pharmacy, and they're on these things all the time, with bloating and distension and pressure in the belly. Often they'll have reflux, and so they're going to the pharmacy and getting, beta blockers, or PPIs, proton pump inhibitors, and working on their own, reflux disease. So these are all just such common conditions, and most people learn to live with them to a certain degree. They're not having good quality of life, but they certainly start to and try to learn to live with them until it gets so severe where they seek out help, or it changes the pathology into more serious conditions. And that's one of the key things I want you guys to be able to get out of this presentation today, is when you understand the pathology of simple things like anxiety, to a certain degree, or depression, low mood depression. We're not talking about clinically depressed people that have to be hospitalized. We're talking about, people that suffer from kind of a low mood every single day, or people that have this chronic basal anxious state that they're in all the time. So they're not so anxious that they can't leave the house. Those extremes are actually a very small percentage of the population. Most of what we're talking about are functional people that are struggling on a day-to-day basis, right? And that's the 40 plus million Americans that are going through that. The thing that's really important to understand is that the pathologies that cause this type of depression, that cause this type of anxiety, that cause IBS, for example, are the same pathologies that lead to dementia, that lead to Alzheimer's, that lead to Parkinson's. And so it's a very serious condition. It just hasn't gotten there yet, right? And that's the part that is really important to understand, right? So we'll go through that, and I'll make sure that's clear how it all connects. And in fact, when you understand the research and you understand the pathology, what you start to understand is that what we feel today as anxiousness, or what we feel today as depression, what we feel today as indigestion through IBS, for example, are all pre-Alzheimer's or pre-dementia symptomologies. Right. And when you put it in that context, it really becomes a profound problem, right? It's something we can live with right now, but in 10, 15, 20 years, it's not something we'll be able to live with at that point. So let's jump into it. We know that the gut and the brain are intimately connected from a physiological standpoint. In fact, from the embryonic stage, they kind of come from the same tissue. The same part of the embryo differentiates into the brain, and especially the blood-brain barrier area and the brain itself, and then also the intestinal epithelium. They come from the same polar region of the tissue. We also know that the vagus nerve is a main connection between the gut and the brain. That's the neurological connection, but there's other connections as well, right? There's your circulatory system. We know that the brain has good blood supply, right? So anything that enters into your circulatory system can make its way to the brain, especially if it can cross the blood-brain barrier. We also know that the lymphatic system makes its way into the brain. It was recently found, and I say recently, I mean about 5 years ago, that the brain has its own lymphatic system. So anything that happens in the immune system is going to impact the brain in some way or the other. And keep in mind that 75, 80+% of all the immune tissue, and arguably all the immune activity in the body, is happening in the gut. And so all of the immune action that occurs in the gut is going to have a translational effect on the brain as well. Here are some intimate connections between the gut and the brain. When you look at the intestinal epithelium, there's something called the enteroendocrine cells. So enteroendocrine cells are these cells that are spaced out in the intestinal epithelium, and they are actually producing hormones and hormone precursors, right? So they are effectively endocrine cells, but they're part of the enterocytes in the lining of the gut. So that's why they're called enteroendocrine cells. These hormones and hormone precursors make their way directly up to the brain through the neurological, lymphatic, or circulatory system. We also know, of course, that I mentioned the immune cells, right? You've got dendritic cells and B cells and T cells, and virtually every immune cell in the body has a function or an action in the gut, and the immune cell action in the gut will have a specific translational effect on the brain. In fact, the immune system becomes a really important part of stress response. We'll talk about how that's connected. We also know that there's a lot of postbiotics that are made by microbes in the gut, things like GABA and 5-HT and serotonin and dopamine and so on. All of these things, including vitamin precursors, urolithins, amino acids and peptides and so on. All of these things have an impact on feeding the brain or influencing the brain as well, and those come directly from the gut. We also know that the gut is surrounded by something called the enteric nervous system. The enteric nervous system is the second largest density of neurological endings in the body. There's over 100 million neurons in the enteric nervous system. So it's even more than the spinal cord. So it's, in many ways, we call this the second brain, but it's really the other brain to me. And even more than that, the gut and the brain are basically the same system. They're just two parts of the same system, right? No different than your two kidneys, maybe on different sides of the body, but they're essentially functioning in many similar ways, and they're connected, and one influences the other, and so on. The gut and the brain are similar in that sense that they support many of the same bodily functions. They communicate with one another. They are autonomous in many ways. The gut is the only organ system that's actually autonomous of the brain. Everything else in your body requires the brain for control, but the gut can operate on its own because it's a second part of that same system, right? So the gut and the brain are exactly the same system, just two different ends of it. And when you look at all the neurotransmitters that are found in the enteric nervous system, they're also found in the central nervous system, right? So same chemical language, same messengers, all of the same things that are found in the endocrine system is also found in the enteric nervous system, or in the neurological system is also found in the enteric nervous system. We also know that it's a bi-directional communication, meaning that we have the ability to influence our gut through our choices, through our behaviors, and then our gut thereby has the ability to influence our brain. So it goes back and forth. One good example that we'll address is the issue of stress, right? So stress, So stress has a huge impact on your microbiome. In particular, because there's lots of opportunistic organisms within the system. So if you look at stress, that are sitting around and waiting for the release of things like norepinephrine, epinephrine, and cortisol, right? So these opportunistic organisms are sitting there, and they're called opportunistic because they only express their virulence factors during certain opportunities. And that's typically when the host is compromised in some form or the other, right? So you've got opportunistic organisms sitting around, low metabolic activity, and then the host undergoes stress. Your epinephrine, norepinephrine levels go up, your cortisol levels go up. These microbes then start to see and read that the host's stress hormones are up. It indicates to these microbes that the host's immune system is compromised. And so they start increasing the expression of their virulence factors, which gives them a leg up in their growth, right? So small bouts of stress throughout the day can have a very negative impact on your microbiome. And when you have continuous small bouts of stress day after day, it's almost the same as taking courses of antibiotics in terms of how it impacts your microbiome. And then keep in mind that these microbes that do really well under these stress states will try to keep the host under stress, right? Because that's the environment under which they thrive. And one of the ways that two of the ways that they keep the host under stress, one, some of these organisms will produce neurotransmitters themselves that actually have a stimulatory effect on the sympathetic nervous system in the host, right? So it keeps the host in the sympathetic state, in this activated stress state. Many of these organisms use inflammation. And as you'll come to see, inflammation is a key part of maintaining or triggering a stress state. And so they favor the idea of increasing inflammation in the body because that inflammatory state keeps the host compromised. So it's a bi-directional highway that's really kind of a loop, because when you have increased stress, you increase dysbiosis, you increase microbes that have virulence factors or capabilities of putting the host into a more stressed state, thereby creating a higher stress state, which thereby feeds them and creates an even better environment for them, right? So the circle keeps going round and round. And then here, this is a really important slide to keep in mind, because this is really your permission and your evidence as to why it's important for you to treat the household, right? If you have a patient that comes in and he or she is under, lots of stress and is dealing with anxiety and can't sleep and maybe has depression to a certain degree and other inflammatory related conditions, and they're very motivated to get better, and you're helping them out, basically when they go home, if they don't go back to a healthy microbial environment, which is typically determined by what the rest of the individuals in the home's microbiomes look like, they're basically taking two steps forward and one step back on their improvement. So this study illustrated that. This study was basically a study on individuals who were given a course of antibiotics at a hospital for whatever reason they went to the hospital, and then the researchers took a bunch of microbiome samples before they started the course of antibiotics, and they profiled their microbiome. Then they took a bunch of samples during the course of antibiotics, and then upwards of 6 months after the course of antibiotics. Not surprisingly, they found that during the course of antibiotics and up to 6 months after, there was a significant amount of dysbiosis that was identified, right? So their microbiomes became altered in an unfavorable way. What was interesting about it is they also followed the microbiomes of household contacts of these individuals. These household contacts were not taking antibiotics, and yet these household contacts saw similar perturbations during and upwards of 6 months after the course of antibiotics was stopped by their roommate or significant other or sibling or whoever whatever the relationship was. And that's an important thing, a note, because these weren't intimate partners necessarily. These were, platonic partners, roommates, siblings, and so on. And what they found is that if you're living in a household with somebody who's undergoing a dysbiotic microbiota, in this case, it was a course of antibiotics, that your microbiome would be negatively impacted as well. Right. So we all live in this microbiome cloud in our households, especially where if the ecosystem in the household is not healthy, then the individual that's trying to get better is going to keep getting setbacks. Right. And often the question is, well, how is it that the antibiotic intake was influencing the other people's microbiomes? Was it that the individual was like oozing out and secreting antimicrobials or antibiotics? That's not the case. It's because individuals shed lots of bacteria throughout the day, whether it's through your skin or through your, bodily fluids like sneezing and coughing, even breathing sheds microbes, right? And then especially defecation, when you go to the toilet and you defecate in the toilet, billions of bacteria from your stool become solubilized in the water. And then when you flush and the toilet spins, you aerosolize many of these microbes. So you've actually got poop microbes from the toilet floating up into the air vent system and getting blown around the house, right? So inevitably, you're sharing microbes from your feces with each other in the household. And so if somebody is on an antibiotic, they start shedding different types of microbes into the environment. They'll shed more Staph aureus, Staph streptococcus, they'll shed, more Klebsiella, they'll shed more dysfunctional bacteria into the environment, or from the skin, they'll start shedding Staph aureus instead of Staph epidermidis. And so they keep putting out dysfunctional bacteria, and the other individuals within the household pick it up. And when they pick it up, it creates dysbiosis in them as well. So if you've got patients that are very motivated to have a change and experience a change, you should absolutely use this information to convince them to treat the whole household. Now, when we think about the gut-brain axis, right, I talked a lot about how the gut and the brain are connected. They're two parts of the same system. They have a significant influence and effect on one another through all these intimate ways that they're connected. But I think one of the most important messages to understand from when it comes to the gut and the brain is that your gut is somewhere on the spectrum of either A, being the most supportive and important thing to your brain, meaning fixing and supporting your brain every single day, every single night, maintaining the health and functionality of your brain. That's on one end of the spectrum, or the other end of the spectrum, arguably the most toxic thing to your brain that you can encounter on a day-to-day basis, right? And I say arguably because, of course, there's some really horrific chemicals you can encounter that are going to be really bad for your brain. But when you just take the individual, the average individual, the life that they lead, the houses that they live in, the cars they drive in, the places they work, a dysfunctional gut is actually the most toxic thing to that person's brain. Right. And this is the important message. Your gut microbiome is somewhere on that spectrum. It's somewhere from the far left-hand side, where it's the most helpful, supportive, protective thing of your brain, all the way to the right-hand side, where it's the most toxic thing to the brain. I would guess that the vast majority of people are leaning more towards the right, where their guts are more toxic to the brain than they should be. And this is probably the biggest driver of brain-related dysfunctions. This is where anxiety comes from. This is where depression comes from. This is where Alzheimer's and so on comes from. And I'll show you now how these conditions are driven by a dysfunctional gut. So there's two big pathologies to keep in mind with the dysfunctional gut. Right. The first one is LPS endotoxin-driven inflammation. Right. So endotoxins, especially LPS, which stands for lipopolysaccharide, are toxins that are made by gram-negative bacteria. And a large chunk of the microbes in your gut, in your body, are gram-negative bacteria. So it's called an endotoxin because it's a toxin that's formed inside the body. It's not one that you can get away from, which is like an exotoxin, right? Mold toxin in the house, for example, would be an exotoxin, where the option is to either remediate the house or move out, right? Endotoxins you can't get away from because they're being generated constantly inside your body itself. So LPS is an incredibly pervasive endotoxin, in particular because of its unique size and shape. And one component of its shape that's really interesting is this fatty acid tail that you see down here, what we call the lipid A tail, right? The lipid A tail with this carbohydrate and sugar head makes it look a lot like your phospholipid bilayer in your cells, right? So this toxin can penetrate virtually every tissue in the body, cross the blood-brain barrier, end up in the brain, which is a high-fat organ system. And so it is incredibly pervasive, and it gets everywhere in the body. And when it gets into the different places in the body, it elicits a very robust inflammatory response. The reason it does that is because your immune system is designed and keyed to looking for LPS, because it's a part of gram-negative bacteria. And lots of the enteric pathogens in the body, and these are pathogens that can typically colonize and infect the gut and make its way into your blood system, because the gut lining is a very thin lining to begin with. So these enteric pathogens have the ability to penetrate into the blood supply through the gut, which then puts the individual in sepsis. Right. And that's bacteremia, sepsis. And that is a very dangerous condition. So your immune system takes this condition very, very seriously. And it's constantly looking for LPS in your circulation, and it's constantly looking for LPS in your different body tissues. When it finds and binds LPS, it elicits a major inflammatory response because your immune system is trying to prevent you from being septic. Right? So that is LPS and LPS endotoxin-driven inflammation. The second part is stress-induced HPA activation, right? And we'll talk about both of these separately. So let's start with LPS. Now, I mentioned that your gut is full of enteric pathogens, right? And 50+% of the microbes in your gut make LPS. Now, LPS normally stays in this upper layer here. I'm going to use some annotation so that I can help point to things a little bit better. Let's see if this works. Okay, so you've got this mucus layer here sitting on your intestinal epithelium. So this is your intestinal epithelium cells. You see these cells sitting shoulder to shoulder. It's basically one cell thick in your digestive tract, right? In between these cells, you have tight junctions. These are spaces, dynamic spaces that have to be able to open and close as needed. Open in order to let bigger molecules through, like nutrients, and close most of the time so that things don't just leak through. And then the other way of getting past the intestinal lining on purpose is something called the transcellular pathway, which is going through the intestinal epithelial cell itself from this top side all the way down to the bottom. Now, most small molecules, minerals and things like that, charged molecules can do this. They can move right through the cell, and that's to allow things like potassium and sodium and so on to be able to get readily absorbed into the system, right? So once it goes past this intestinal epithelium, it ends up in this region. This is called the basolateral circulation. In this region, you're basically finally inside the body. When you're in the digestive tract, if you haven't crossed through this lining of the gut, you're still technically not inside the body. You're officially inside once you get to this area. This is called the lamina propria, or the basolateral circulation. Now, about 85% of everything that ends up here ends up in the liver first, right? It goes through something called portal circulation. It goes from the gut lining to the liver, and then the liver figures out what to do with it. Right? Whether it's a compound, nutrient, toxin, whatever it may be. But about 15% of everything that makes its way through here ends up directly in circulation. So if you've got a bunch of LPS that's making its way through and ending up here, a good bit of it is going to end up in circulation. And using circulation, it gets throughout the body and it wreaks havoc in terms of the immune response to it. Now, what's important to acknowledge here is this unique mucosal structure on the intestinal epithelium. You've got two distinct layers to the mucosa. You've got this inner layer here called the mucin 2 layer. As you can see, it's depicted as being relatively sterile. And it is. It's one of the only regions in the body where you don't find microbes growing. And what's interesting about it is that it's exactly underneath the most densely populated area of microbial growth in the body, which is in the digestive tract in this top layer called mucin 1 layer, right? So mucin 2, relatively sterile, and then mucin 1 layer is where most of the microbes in the body live. So there's a specific reason why mucin 2 is relatively sterile, right? Your immune cells that are embedded within your intestinal epithelium are very reactive. And like I mentioned earlier, they're constantly looking for microbes that are trying to break through and end up in the blood in large amounts and create sepsis, right? Because they're so in tune to that, the immune cells in your intestinal epithelium are only comfortable if there is a geographic separation between them and the trillions of bacteria and viruses and so on that live up in the mucin 1 layer. This mucin 2 layer, this relatively sterile layer, is that geographic separation. It provides the immune system with a demilitarized zone, if you will, right? Where there's no danger, the microbes are still, a layer above, so they're not really posing a threat. and the threat of things just busting through the lining of the gut and ending up in circulation is very, very small. So your immune system really likes to maintain the sterility and the size and distance, size and shape of the mucin 2 layer. Then the layer above that is the mucin 1 layer, where the vast majority of microbes live in your gut. Right? So you've got these two distinct structures, and this is really, really important to know this, because the vast majority of diseases, chronic diseases in the Western world, start because something happens to this mucin 2 layer. It starts to get damaged, right? And the big problem with that is once it starts to get damaged, microbes up here will start translocating or moving in closer to the intestinal epithelium. The moment it gets to the intestinal epithelium, it causes the intestinal epithelium to really freak out, recruiting lots of innate immune cells to the area that will start banging the area with inflammation. And that inflammation will eventually actually damage the intestinal epithelial cells, leaving big gaps in it, creating very profound leaky gut. Right. So this is a really, really important component of the pathophysiology of what's happening in the lining of the gut. Now, to maintain this type of homeostatic structure, what we basically need is very high diversity, high alpha diversity. That's a high number of different species that are living in your gut. You also need high levels of these protective keystone species. These organisms are ones like Akkermansia muciniphila, Faecalibacter prosnitzi, Bifidobacterium longum. All of these types of organisms are designed by nature to continuously maintain and rebuild the structure. Even if you get some of this mucin 2 layer eaten away, if you have the healthy microbes in the system, they can rebuild it pretty quickly, right? So these green cells, goblet cells, for example, are the mucin producing cells. They produce this mucin 2 layer, but their number one food source is butyrate, which is what's required for them to function properly. And unless you have high degrees of protective strains, almost all of which produce butyrate, you're not going to get adequate levels of butyrate into your intestinal lining, and thereby the goblet cells won't have enough energy to produce the mucin 2 layer, right? So that's where the short chain fatty acids come from. That's butyrate. And then, of course, having well-formed tight junctions, that's also largely controlled by the microbiome. And the expression of tight junction proteins is controlled by the gut microbiome. Now, what starts happening in dysbiosis, right? When you want to define dysbiosis, it's actually a pretty simple definition. Dysbiosis is really the imbalance of microbes that eat away at the mucin 2 layer versus microbes that rebuild the mucin 2 layer. Right? That is the simplest way to think about dysbiosis and its relationship to disease, because what happens is you start getting an overgrowth of microbes that eat away at the mucin layer. You start getting this net reduction in the mucin 2 layer, and then a translocation of lots of microbes from the mucin 1 layer too close to the intestinal epithelium. That causes the intestinal epithelium to start releasing lots of cytokines to try to recruit innate immune cells to the region. When innate immune cells come to the region, they're going to bombard everything, including the intestinal epithelial cells, leaving big gaps and holes in the lining of the gut, allowing for things to leak through that normally shouldn't, like LPS, the endotoxin. Now, LPS is so pervasive that once it gets into the gut, it goes throughout the body and especially into the brain, right? So LPS has the ability to find its way to the brain. It can cross the blood-brain barrier, and once it's in the brain, it elicits a whole bunch of inflammatory processes, not only in the brain, but all over the central nervous system as well. So what happens when you have elevated levels of LPS in the central nervous system or in circulation, or certainly in the brain? Well, number one, LPS induces inflammation. Right? When your immune system encounters free LPS floating around in your body, it elicits a pretty powerful inflammatory response, because again, it's trying to control whether or not there's trillions of more LPS bearing gram-negative bacteria entering into the system. So it's gonna elicit a pretty robust response to the presence of that LPS. and that robust response is a cytokine response, right? And so what some of these studies have shown, this is an animal study, by the way. I'll show you some human studies as well. What they were able to show is that increased enteric load of LPS increases anxiety, right? So they've pointed out and made it relatively clear that increased LPS in circulation creates anxiety-like behavior in both sexes, and it does so through an inflammatory mechanism that you'll see a little bit more in some of these human studies. So here's a human study. It's the Netherlands study of depression and anxiety. This is a long, I think it was if I'm not mistaken, 16-month study. 9-year study, not 60-month. 60-month was a diabetes study. This is a 9-year follow-up study looking at biomarkers that were predictive of the development of anxiety and depression. And so they looked at inflammation and inflammatory biomarkers. And what they found was that LPS, so basal inflammation and LPS-stimulated inflammation and inflammatory markers were more strongly associated with sickness behaviors. This is a subset of major depressive disorders. Conditions such as anhedonia, anorexia, low concentration, low energy, and so on, that the presence of these inflammatory drivers were more associated with sickness behaviors. And this is true up to 9 years of follow-up with these individuals, right? So basically, they were looking at individuals that have anxiety or depression type of symptoms. They looked at a number of different biomarkers in these individuals to see what was maybe predictive of the presence of anxiety, depression-like symptoms. And then they notated all of those biomarkers. And then upwards of 9 years later, they followed these individuals and then looked at their symptoms to see if they were still experiencing anxiety and depression, and if concurrently they were still being exposed to things like LPS and other biomarkers. And they found of all the biomarkers, LPS was the most predictive of the presence of anxiety and depression in these individuals, right? So having elevated LPS through a leaky gut is a core fundamental component of having anxiety and depression. There's more data that shows, from this type of study that shows the same exact thing. And in fact, they showed that LPS-stimulated inflammation was associated with increased odds of current depressive anxiety symptoms, very strong p-values. And so what they also found is that LPS-stimulated inflammation was associated with more severe depression and anxiety symptoms, as was basal inflammation. And unlike basal inflammation, LPS-stimulated inflammation was still associated with anxiety symptoms and severity after adjustment for lifestyle and health disorders. So basal inflammation, when you had a certain lifestyle disorder, like, for example, you were overweight, right? And there is associated basal inflammation with being overweight. What they found was that even when you correct for all these lifestyle factors, when you basically have what would be considered healthy, normal individuals, normal body weight, no cardiovascular disease that's known, no diabetes, and so on. If they had elevated levels of LPS, they still had a very high risk of anxiety and depression. And these are all the biomarkers that are typically increased when you have increased levels of LPS, IL-8, MCP1, IL-6, and so on. So this was really profound because it's showing kind of an underlying root cause driver of anxiety and depression. And this big major driver of anxiety and depression is coming from the gut. And it's coming from a leaky gut, especially, right? When there's intestinal barrier dysfunction, you get elevated levels of LPS in the system. Elevated levels of LPS induce an inflammatory response, and that associated inflammatory response triggers flight or fight response and increases cortisol, increases epinephrine, norepinephrine, and reduces anti-inflammatory cytokines like IL-10, for example, right? So no doubt that LPS is associated with anxiety and depression. Now, not only is it bad that LPS in circulation means that you're much higher risk for developing anxiety and depression. That same LPS accumulating at levels in your system and gaining exposure to the brain is also the main thing that drives Alzheimer's disease, right? So in 2017, it was discovered that microbiome-derived lipopolysaccharide was found to be enriched in the perinuclear region of the Alzheimer's disease brain, right? So this basically means that in individuals that suffered from Alzheimer's, they found lots of accumulated lipopolysaccharide or LPS in the perinuclear region of the brain, right? So LPS is likely the primary insult that kicks off this inflammatory cascade in the brain that eventually damages the brain tissue, so because the brain can't fix it fast enough, and it damages the brain tissue over time, and that damaged brain tissue will start to look like Alzheimer's, Parkinson's, dementia, and so on, right? So this is why there's a strong connection between the anxiety we experience today, or the depression, or the major depressive disorders, sickness behaviors, all of those symptomologies, and how it's connected to the longevity of the brain, right? Same exact mechanism. Elevated LPS leads to elevated inflammation in the central nervous system. That elevated inflammation in the case of Alzheimer's causes the destruction of central nervous system cells, or in the case of anxiety and depression, you start to get increasing symptomology of both anxiety and depression. Same thing happens in Parkinson's. Gut permeability and the exposure to endotoxins creates damage to the central nervous system, which can be measured over time. And then it becomes very clear, and this is what the research has shown, is that this continuous exposure to lipopolysaccharide through permeable intestines is the key insult to the vagus nerve and to the central nervous system that leads to the symptomologies that look like Parkinson's disease. And if it wasn't enough that you have anxiety, depression, Alzheimer's, Parkinson's, LPS in circulation induces a low-grade inflammatory increase in the hypothalamus, which creates then something called central insulin resistance, where you're now become type 2 diabetic, even though you might have perfectly functioning islet cells producing enough insulin in your body. You can't utilize the insulin because your brain can't read your blood sugar levels, right? So this is irrespective of body weight. This is the explanation for why we're seeing younger and younger individuals being diagnosed with type 2 diabetes, especially ones of normal body weight. You would never think someone in their early 20s would be diagnosed with type 2 diabetes, and especially if they're looking relatively fit, but this is happening now. And the reason is because LPS-induced inflammatory damage to the brain creates these types of issues. In this case, one of the key issues is your brain's inability to read your blood sugar levels. And we know that the gut-brain barrier, when you look at major depressive disorders, papers like this, good review papers, show you the mucosal dysfunction with translocation of LPS from the gram-negative bacteria, which they call leaky gut, in a correct manner, and how it plays a role in the inflammatory pathophysiology of depression. So remember, depression, anxiety, Alzheimer's, Parkinson's, type 2 diabetes, IBS, SIBO, which is a component of IBS, all of these conditions are gut-brain conditions. All of these conditions have major impact from LPS, lipopolysaccharides, and all of these conditions can coexist in one individual because that one individual has some of the underlying risk factors that drive all of these conditions, right? These aren't separate conditions. They're just different on the timeline, right? What we may be experiencing right now is anxiety. Down the road, and when we reach a different time point, that can start looking like Alzheimer's or dementia or Parkinson's. So how do you support a healthy gut barrier and stop LPS translocation? This was actually the primary focus of Microbiome Labs. We started the company with a goal of resolving leaky gut using bacterial therapy, right? Because this work had been done on animals, decades prior. And so looking at the animal work, this is animals like pigs and chickens and so on at these big farms. They're trying to reduce the mortality rate on these organisms. So they're trying to maintain a strong intestinal barrier and not increase the leakiness of the barrier. And so they've been studying probiotics for this very purpose, right? So probiotics have been studied in veterinary medicine, especially Bacillus endospores, for their ability to seal up the lining of the gut, rebuild the mucosal structure, increase the expression of tight junction proteins, increase some of the anti-inflammatory cytokines, so it reduces the inflammation associated with people getting stressed. And so they've been studying this in animals for some time, and they found that these Bacillus endospores were very potent at doing this. And so when we discovered our Bacillus endospores, and we tested them inside and out, they're all human-derived, meaning they're natural colonizers in the human gut. We first wanted to see, would these organisms also help leaky gut, right, in individuals? And so that's how we published our very first study that was published in 2017 in the World Journal of Gastrointestinal Pathophysiology. What we basically showed with Megaspore is that when we screened about 100 college kids, about half of them had very severe endotoxemia or very severe leaky gut, where LPS floods into their system after a meal, for example, right? So we recruited those individuals that had really bad leaky gut. We put them in the study. We gave them either 2 caps of placebo, which was just rice flour, or we gave them 2 caps of Megaspore. And this is the initial study, this is the expanded study data where we see about a 45% reduction in LPS endotoxemia in spore-treated individuals. And the crazy thing about this is with the placebo group, not only did they not see a reduction, they actually saw a 32% increase in the amount of LPS that was translocating or leaking into their system, right? So we have over a 60% difference between the treatment group and the placebo group in this study. This was a 50-patient study. We've just finished a study that was, I think, 2.5, 3 times the size, and it ran for 2.5 times longer as well, because what we really wanted to see is what continues to happen with this placebo group. Does it go up and down, or does it continuously increase over time? If it continuously increases over time, that would be a significant issue, because it shows that people's guts are just becoming leakier and leakier and leakier as days go by, right? And remember, once you get to a certain level of leakiness and inflammation, that starts to trigger a lot of the symptomologies that we come to know as depression, anxiety, and then down the road, dementia, and so on, right? So a massive treatment effect when it came to LPS endotoxemia with Megaspore Biotic. We also saw that a number of key inflammatory markers were increased dramatically in the placebo group, because their endotoxemia increased, and would dramatically decrease in the treatment group, which was concurrent with the decrease of their endotoxemia. So all of these conditions, and this is a heat map if you're not familiar with it. So this left-hand side is a spore-based group, their baseline numbers compared to their post-30-day numbers. And then in the placebo group, again, their baseline numbers compared to post-30 days. And if it becomes red or orange, it means that the numbers are increasing towards the unfavorable way. And if it becomes more green and yellow, it means the numbers are decreasing, meaning in a favorable way, right? So when you look at all of these quintessential inflammatory markers like IL-6, IL-1 beta, IL-12, MCP-1, these are all the exact biomarkers that are implicated in gut-brain dysfunctions. And these are the same biomarkers that drive inflammatory damage to areas like the central nervous system and so on, right? And in the case of the spore-based probiotics, not only did these numbers not change, not only did they didn't get worse, they got significantly better, unlike the placebo group, where they did get significantly worse. So if you look at the spore-based group, you can see they have significantly less inflammation in general than the placebo group. All these other biomarkers below this line did not reach statistical significance, which means a p-value of 0.005. What we did see was that they were trending in this right direction. Now, one of the first pieces of evidence that we saw that we thought was a affirmation that even in that study of leaky gut individuals, we were reestablishing some gut-brain connection. So if you look here, ghrelin is the hunger hormone, right? So ghrelin is released in your body, triggered by your brain to release ghrelin when you are hungry, when your digestive tract is empty and you need to get more food into your system. And so ghrelin being the hunger hormone, when you're fasted, which is the key at time zero, all these individuals came into the clinic in a fasted state. The ghrelin levels would be high, but then we give them a 2,000 calorie meal here, and you see the ghrelin levels barely drop and start to increase again pretty quickly, right? Which means that the body is really not utilizing all of these calories in the most effective format, and the body's also likely not breaking down enough and assimilating many of these compounds because the body still thinks you're hungry. Right. And so it continues to release ghrelin. At the same time, what it's supposed to do is reduce ghrelin and increase leptin, which is a satiety hormone. Now, when you look at the post-probiotic treatment groups, right? So this is a group that got nothing but the probiotic, no placebo. They already came in with a slightly reduced ghrelin level, even in a fasted state. But then when we gave them a 2,000 calorie meal, we see the ghrelin levels drop quite steadily, exactly the way it's supposed to, right? And that's because it creates, it stimulates a lack of appetite in these individuals. Once they've eaten and they have enough calories, their body's satiated, they don't need any further food, so they don't overeat. Right. And that's a key component to staying lean and fit and healthy, is that not overeating. And so the ghrelin response is a critical one here, because what you start to get is this ghrelin leptin resistance when your gut is dysbiotic and it's not speaking to the brain. Right. So if your gut is leaky, if your gut is dysbiotic, it's not talking to the brain. That means you can bring in food, you can have adequate amounts of caloric food in your gut, and yet your gut's not sending signals to the brain telling it to stop producing hunger hormone. Right. So this is a very significant finding because it number one, shows a gut-brain response. But number two, this also became the basis for us doing our metabolic health study, where we looked at individuals to see if we can get them to lose weight just by giving them the probiotic and one prebiotic. Right. And sure enough, we published that study at the end of last year. We were able to see a 35% reduction in visceral fat mass in overweight individuals in a 90-day period, without any diet and without any exercise, right? No change in diet, no change in what they're doing, no change in activity, and yet a 35% reduction in visceral fat mass, right? When we reestablish components of the gut. So that's the first part. That's LPS-induced inflammation and damage to the gut, right? And the brain. And so what we know is that when you have elevated levels of LPS in circulation, that puts you at significant risk for anxiety and depression and major depressive disorders, sickness behaviors, and so on. We also know that those same risks translate towards developing Alzheimer's and Parkinson's and dementia. That same pathways are also the ones that trigger a damage to the brain, the hypothalamus, where now your brain cannot read your blood sugar levels. We also know it has an impact on metabolic health, right? It causes you to put on weight because you're not getting the proper ghrelin and leptin response post-meal. So when you put all of that together, basically it becomes really clear that if you have elevated levels of LPS in circulation, you are at significantly higher risk for all of these symptomologies, right? So one of the first things we need to do in order to stop a gut that is toxic to the brain is to stop the translocation of LPS in that gut. Spore-based probiotics, fortunately, are able to do that, and we've got a few different studies to be able to show that. The second part I want to address is stress-induced HPA activation. Before that, we have to look for a moment at what happens in the body when you are under stress. So let's say you experience an external stressor, and it doesn't have to be anything big. It could be, somebody cutting you off in traffic, or a message or text message that you got in the morning that's making you feel stressed. Any kind of external stressor will trigger the pituitary gland to release something called CRH, which is corticotropin releasing hormone. That activates the pituitary gland to release ACTH, which then activates the adrenals to release cortisol, right? So this is all happening in a split second when you experience a stressor. Now, on the other side of this movement, you've got through the brainstem an activation of the sympathetic nervous system. Now, the sympathetic nervous system is trying to make a couple of changes in your body as you experience stress, because keep in mind, from an evolutionary perspective, stress is a flight or fight response for us, right? When we experience stress and we experience anxiousness, we get into flight or fight mode. That is, whether it's your sympathetic, which is the flight or fight, or the parasympathetic, which is the rest, digest, and recovery neurological systems, which one is more activated? Under a stress state, you've got the sympathetic nervous system that's getting you ready to be able to fight or flee. Now, how does it do that? It does a couple of things. Number one, the sympathetic nervous system increases your respiratory rate. So now you're breathing harder, right? And your heart is hopefully pumping more blood throughout the body, because the goal of the fight or flight response is to get blood to the brain, to the heart, and other muscles, so that you can be visually and auditorily very acute, and it's easier to make decisions quickly. And then also you need to be able to run and or defend yourself, and so you need more blood and more supply of energy to your muscles and your brain. And so it's increasing respiratory rate to do that. It's also using inflammation as the way of getting inflammatory, way of getting blood perfusion into areas like the brain. So the sympathetic nervous system releases something called catecholamines, which will then increase something called NF-kappa B in your neurons, and that NF-kappa B will increase a pro-inflammatory cytokine. The NF-kappa B is released by macrophages, dendritic cells, and microglia cells, all that are found circulating all throughout your body, including in your central nervous system. In your central nervous system, it's the microglia cell that's acting like a macrophage. So the sympathetic nervous system irritates and activates macrophages and microglia cells, and dendritic cells to a certain degree. And these cells release all of these pro-inflammatory cytokines to try to get more blood to your brain and your heart and your muscles, right? This is what's happening. Now you're, with cortisol being elevated and your sympathetic nervous system being on, you are in a position to make a decision to fight or flee. Now, no matter what you do, what you need to be able to do is come down from this state of anxiousness and this fight or flight response, right? That is one of the most important things, because we cannot stay in the sympathetic state throughout the day where we're constantly in fight or flight, because when we're not in the parasympathetic, we're not digesting appropriately, we're not assimilating nutrients, we're not resting, we're not recovering, we're not doing all of the important things that need to get done in the body. We're not doing any of those things when we're in a excited, elevated state, right? And so being able to come down from this becomes really critical. Now, here's how you come down from this. This is where cortisol comes in handy again. Cortisol, a part of it, gets dumped into the gut as the cortisol levels are increasing in the body. Now, one of the reasons it gets dumped into the gut is part of the cortisol is actually metabolized into compounds that are sent to the kidneys that increase the amount of fluid that the kidneys push back into circulation. When they do that, they're increasing blood pressure, and the blood pressure will increase perfusion, right? This is how chronic stress can create hypertension in individuals. It's through the kidneys, and it's through the metabolization of cortisol in the gut. Now, the other thing that cortisol is supposed to do as it starts accumulating in the body, gets dumped into the gut, and so on, is to start binding glucocorticoid receptors. This is the off switch for this whole fight or flight response. And when you bind enough glucocorticoid receptors, it signals to the body that, hey, we've gone through a big cortisol curve. We're coming down from it now. We need to shut down all of this and go back to leaning towards a parasympathetic neurological activation. And so unless you can bind effectively to these glucocorticoid receptors, it becomes very hard to turn this system off, right? And so a single stressor early in the morning can keep you in a basal stress state through the rest of the day, because now you are constantly in the sympathetic state, right? So this is what's happening in the body during a normal stress response. Now, there's an issue called chronic cortisol expression. The reason why this is an issue is because what happens in the gut when cortisol dumps into the gut, if your gut is dysbiotic, meaning especially if you're missing a very critical component of your gut, what tends to happen is cortisol also creates significant amount of hyperpermeability in the gut for the short term, right? And basically that then increases inflammation, because we know leaky gut increases inflammation, and that inflammation can re-trigger the HPA axis again. So let me go through that for a second. So with increased levels of cortisol, there's an increase in permeability in the wall and lining of the gut, right? This facilitates a systemic inflammatory response. So now you're getting leaky gut as part of the flight or fight response. Now, one of the big problems is when you have leaky gut, you get an increased level of circulating TNF alpha, interferon gamma, and IL-6, right? These are quintessential inflammatory markers that get increased when your gut is leaky, when you have LPS and other things leaking through. Now, here's the big problem. IL-6 is known to be able to go and reactivate the HPA axis. This is one of the ways in which difficult organisms who are opportunistic, who want the host to be in a flight or fight state, who wants the host's immune system to be suppressed, those species can actually increase IL-6. That's one of the ways in which they do it. But cortisol will also increase IL-6 if you don't have a healthy gut. And we'll talk about what a healthy gut looks like from the perspective of stress response and not allowing cortisol to increase intestinal permeability, right? So what happens now? Cortisol is dumping in, intestinal permeability is going up, you've got chronic low-grade inflammation increasing, you've got higher levels of IL-6. That has reactivate the hypothalamus pituitary adrenal axis. That is causing more cortisol to be released, more cortisol to be dumped in the gut, and then more leakiness to occur as a result, creating this nonstop cycle of reactivation of the HPA axis. So a single stressor in the morning can keep you in this basal state of inflammation and stress because your HPA axis keeps getting reactivated. And it also downregulates the expression of glucocorticoid receptors. Remember, glucocorticoid receptors are the off switch. Your cortisol needs to be able to bind these receptors in order to turn off the HPA activation, right? And if you have fewer glucocorticoid receptors, you're not getting a binding saturation effect. So it becomes harder and harder to come down from this stress state. Even though the machinery is there, you can't bind the glucocorticoids through the receptor in order to turn off the machine. Another really bad part about this is it also shows that when you have this continuous increase in IL-6 and changes in the hippocampal serotonin levels, you also start reducing the production of BDNF, which is brain-derived neurotropic factor. Now, brain-derived neurotropic factor is really important in the evenings when you go to sleep, because that's what's going to be repairing your brain every night so that when you wake up, you're fresh again, right? And so if you have a lack of expression of BDNF, then the day's inflammatory damage to the brain doesn't get fixed overnight. And you're likely not sleeping well anyway, because all of this is connected to sleep as well. And so now what you're experiencing is this frequent flight or fight response. You're in this kind of elevated basal state. And because of that, your HPA axis keeps getting reactivated. Your gut has become really leaky because cortisol creates significant leakiness in the gut. And you can't repair your brain effectively enough at night as you go to sleep. So you can see over time, you end up with net damage that actually becomes symptomatic, like in the case of Alzheimer's. There's another big issue that occurs when you're in this chronic inflammatory state, and that's a dysfunction in the metabolization of tryptophan. Tryptophan normally is converted in the central nervous system to serotonin and then melatonin. As you know, most of these are neuroprotective and really good for the system. But when you're in this inflamed state and you have chronic activation of the HPA axis, you've got elevated IL-6, interferon gamma, and so on, it actually shifts tryptophan metabolism to something called kynurenine and quinolinic acid. So kynurenine and quinolinic acid are neurotoxic, right? So tryptophan, which is an important amino acid, normally is good to try to increase serotonin and melatonin. In this case, in this individual who's likely experiencing anxiety and depression, giving tryptophan or increasing the consumption of tryptophan actually will make the problem worse, because most of it is being converted to kynurenine and quinolinic acid as well. LPS can do the same thing. When you have elevated levels of LPS in the body, it shifts tryptophan metabolism to increase the production of quinolinic acid as well, and does so in the synaptic regions. So how do you address stress-induced HPA activation? I kept saying that there is a key missing component in the gut of individuals that suffer through severe intestinal permeability from cortisol. That key component is something called peptidoglycan. Peptidoglycan is a bacterial byproduct. It's a carbohydrate made by certain specialized microbes. Now, these microbes and their peptidoglycan was extremely important from day one of your gestation, because in fact, the placenta, the baby's placenta has both peptidoglycan receptors and carriers, and mom's good gut bacteria are spitting out peptidoglycan into her circulatory system. And it's so important for the baby that there's receptors on the placenta that'll grab the peptidoglycan, take it through the cord blood, take it to the baby's brain, where the baby's brain has receptors and transporters as well for peptidoglycan. And when the baby's brain binds this peptidoglycan, you basically get an increase in the proliferation of brain tissue, so better development of the brain tissue, differentiation of the different parts of the brain, synaptogenesis, which is the formation of the synaptic regions. We know that IQ and cognitive function, all of that is directly associated with the number of synaptic regions in an individual's brains. Myelination, which is putting the insulation on in our central nervous system and our brain as it relates to that. And then the formation of the blood-brain barrier as well. So arguably, some of the most important things we want to happen to our baby's brains. And we've outsourced that to a bacterial byproduct, right? So just think about that. We don't have this genetic way of inducing the growth of our baby's brains. We outsource it to a bacterial product. Now, this peptidoglycan, since utero, has always been important even for grown adult individuals, because it is this peptidoglycan that's produced from certain types of microbes that is the key thing that stops the inflammatory damage that is caused by cortisol in the gut. And it stops the leakiness in the gut and the expression of IL-6, interferon gamma, and the reactivation of the HPA axis, right? So you see that here. With interferons, you see a significant reduction here with the rich peptidoglycan strains. You also see that the peptidoglycan from these organisms can shift tryptophan metabolism back to serotonin and melatonin as well, right? So peptidoglycan can do all of these things. Peptidoglycan is found on the cell surface of very specialized microorganisms, in our case, Bifidobacterium longum 1714. Keep in mind that most Bifidobacterium longums don't have this unique exopolysaccharide that you can see here in this electron micrograph, right? It looks like a bunch of little hairs or spikes coming out of this organism, but all of that is a very unique carbohydrate that cloaks the organism. And as a component of the carbohydrates of the organisms, you have peptidoglycan as well. So we have a strain called Bifidobacterium longum 1714, a very important and probably one of the first psychobiotics about 8 published papers on it, and millions of users globally, because we actually have it in lots of different countries, in about 27 different countries. And we've got a significant number of studies looking at its mechanism of action. So it starts with the preclinical mouse inflammatory studies, and basically we saw across the board that this strain dramatically reduces inflammation, right? And it can be inflammation that's induced by LPS. So in this case, what they would do is inject a lipopolysaccharide into the circulatory system of these animals, looking for an elevated expression of all of these inflammatory markers. And yet, when you dose the animal up with the 1714 strain, you see a complete negating of this inflammatory activation. So not only does it stop inflammation from cortisol and the resulting leakiness in the gut, it can even do it from LPS that may have leaked through the system. So those are just the mouse model studies. In the interest of time, I'll go through this really quickly. But when you look at the human clinical trials, there are now, I think, 4 completed studies on anxiety and mood disorders, right? A good mix of men and women and so on. This is one of the first studies that were done in men only in this case. But we've since done studies with dozens upon dozens of women and dozens upon dozens of men as well. But basically, what the study showed is that the 1714 strain reduced the perceived stress and cortisol output in these healthy male volunteers, with a reduction in the pro-inflammatory tone of these subjects, especially pro-inflammatory cytokines like IL-1 beta, IL-6, TNF-alpha, and so on. Remember, these are the inflammatory cytokines that drive HPA reactivation, right? So we're able to show right off the bat that the 1714 strain reduces the perception of stress, reduces the cortisol response from stress, and at the same time, it stops the gut from becoming leaky and increasing the expression of all of these cytokines as well. Now, another very interesting aspect, and that's the mood component. So we have a low mood, mild depression study, anxiety study, a number of different studies showing a significant improvement in mood and perception from individuals who start taking the 1714. But here's a very fascinating study looking at brain scan activity of individuals that were taking 1714 and who were playing a game where stress was induced. So this was done by Professor Paul Enck in this wonderful little machine here that you can see. So basically, individuals, healthy young individuals, are put in this machine and they're playing a cyberball game with 2 other players. What they don't know is that the 2 other players are actually bots or the computer. And basically, the 2 other players don't throw the ball to the 3rd player, right? And it's surprising how much social anxiety that induces in individuals. And all of that can be measured through the brain scan activity, right? So this is what the study that Paul Enck designed to bring in individuals, dose them up either on placebo or the 1714 strain. And then after 4 weeks of dosing up either on placebo or 1714 strain, they would bring them into the lab and have them undergo the social anxiety type of program. And then they would measure their brainwave activity to see what part of the brain was being turned on in these different cases. Now, what's super interesting, when you look at the placebo and you look at the theta wave band, you see no activity at all, right? And even if you look at beta band, you see almost no activity at all in the placebo group. And yet in the 1714 group, you see all of this activation in the theta wave band. Now that's super exciting because the theta wave band is the what we call kind of the flow state. That's where you have the very high capability of dealing with adverse events and stresses and thinking about things rationally and all that. That's in fact the theta wave band is the goal of meditation. Meditation, if you do it right, puts you into that theta wave state, right? So you're much more calm, you're much more lucid, you can deal with problems as they come along and so on. So it's a very, very important finding that not only do these microbes have the ability to prevent the leakiness in the gut that cortisol creates, prevent the expression of all those inflammatory cytokines, reduce cortisol response in response to stress, because the cortisol is reflective of how the intensity of the stress looks like. and also prevent the reactivation of the HPA axis, right? So it has a profound impact on how your body deals with stress. And then when you look at the brain, it's basically turning on calmness in the brain, which is super interesting, again, which is non-inflammatory, really good for the system in general. So in conclusion, between all the trials, we know that the 1714 strain is a powerful anti-inflammatory strain. We know that it activates certain centers of the brain that are really favorable, that are very good for vitality, for example, that are good for dealing with stressful states throughout the day. But more importantly, it's just a healthier brainwave activity, healthier brain, because there's not so much inflammation in the brain like there is when you don't have the 1714 strain on, and you're getting stressed and continuously activated through your sympathetic nervous system. We also have shown in at least 2 studies that it dramatically improves the indices of sleep. So shorter time to sleep and better efficiency of sleep throughout the night as well. So in conclusion, the brain we know is profoundly affected by inflammation, which is likely the primary driver of cognitive dysfunctions, and major cause of inflammation is the dysbiotic gut, right? We know that dysfunctional gut, missing certain organisms, in the case of Bifidobacterium 1714 with that exopolysaccharide coating, when you're missing those types of microorganisms in your gut, you will induce a temporary leakiness in the gut from your cortisol response. It does become harder to come down from that inflammatory response and the stress response. And we also know that you have a net damage of inflammation to the system over time, right? So now, when you look at this ability to affect LPS and affect HPA reactivation, when you can address both of them together, then you have truly what we call comprehensive brain support, right? So induced HPA activation is taken care of by ZenBiome, which is the 1714 base products. And then the LPS endotoxin-driven inflammation is taken care of by Megaspore Biotic. We have clinical studies in all of these to prove this. Megaspore actually has 12 studies published now. It's one of the most well-studied probiotic formulas on the marketplace. It's by far the most well-studied, if not the only studied spore-based probiotic solution on the marketplace. And there's another important thing to mention here, and that is the concept of whether or not your probiotics are silent or loud, right? And what do I mean by that? One of the key things that we test when we start working with the probiotic strain is what is its response to the immune system, right? And as it turns out, the vast majority of probiotic bacteria that we tested, Bifidobacteria included, are actually loud in the immune system, meaning they induce inflammatory responses, right? And many bacteria are supposed to do that, right? That's the way it trains your immune system. So if you're a healthy individual just trying to boost your immune response, it may be fine to take a regular probiotic that upregulates inflammatory response in the body, because it's teasing and training the immune system, if you will. But if you already have inflammatory conditions, you do not want a probiotic that increases inflammation in any way at all. What you do want is what we call a silent bacteria, which actually doesn't have any increased impact of inflammation on the immune system. And in fact, it does the opposite, where it drives anti-inflammatory response in the system. The 1714 strain and all the spores are silent microbes in that respect. So they're ideal for anyone, even with inflammatory conditions, right? So now ZenBiome is formulated into 2 separate formulas. One is called COPE, one is called Sleep. The COPE is taken during the day if the problem with the patient is daytime anxiety and mood and stress disorders. With the COPE, there's a couple of B vitamins, which actually help some of the mechanism of action. But more importantly, it also has saffron in it. And saffron is really soothing to the central nervous system, right? It brings down the inflammation as well. So it's well paired with the saffron. In the sleep for the evening, if the individual is struggling from sleep issues, then they would take the sleep in the evening. That's combined with L-theanine and lemon balm, which also helps support the sleep mechanism. And if they're suffering from both daytime stress and nighttime sleep issues, they take one ZenBiome coat during the day and one sleep at night. So that's a ZenBiome suite. And then, of course, we have Megaspore Biotic, which is 2 caps per day, although we titrate most people up slowly over time. So I think this is what we call total cognitive support. So I think that's the last slide. I'm sure we went over time a little bit, but I don't know if there were any questions that I need to address.
Thank you so much. Yes, there definitely are some questions in here.
Yeah.
And I'm going to focus, we've got some questions that are about things outside of the topic. I'm going to hold on those for right now. We're really going to focus on very specifically what we're chatting about here. So Laura asks, how do you test for LPS stimulated inflammation?
Yeah, so the markers, okay, so you can't, in the clinic, you cannot test directly for LPS. It's very hard to do because once you pull serum out of the body, which is where you find the LPS has about a 4-hour half-life when it's pulled out of the body. So you can't get the sample fast enough to the lab in order to be able to test it. So you do have to test surrogate markers, which are the inflammatory markers associated with increased LPS. Some of those are something called SCD14, so soluble CD14. That's an immune component that can be tested by most of the big labs at Quest and so on. You also look at IL-6, TNF alpha, and IL-1 beta. So those are the key inflammatory markers that tend to be elevated from LPS.
Awesome. Harry asks, do you feel that high levels of LPS can lead to random sporadic seizures when all other neurological testing is normal?
I wouldn't be surprised, yes, because elevated levels of LPS it absolutely impacts the central nervous system, right? The brain and so on. And it causes massive amounts of inflammation. It can even drive demyelination. And demyelination could be part of that pathology and process. So I would not at all be surprised if that was a trigger or mechanism that can occur for individuals, especially if all of the neurological testing is normal.
Ellen's asking as to why Megaspore seems to be constipating for so many clients and how to make it easier to tolerate. Now, I did see that Karen responded here about recommending to take the HU58 first, but if you had anything you wanted to add to that.
Yeah, that's actually a great recommendation from Karen. I think normally what we do is we see that if it's going to induce constipation, which in our kind of empirical data, we see that occurs in about 10% or so of people that take it. It normally occurs in the first 4 or 5 days and usually doesn't really last much longer than the first week. So you just kind of work through it. And in fact, in many cases, we find that if you just go to the higher dose, it actually pushes them through it faster. And they can have normal bowel movements, right? Normally, the response is to back off a little bit, but in this case, you kind of push forward through it, and it normally helps them resume their normal bowel movements. The reason I think that happens, and we haven't looked at the specific mechanism of action, but the reason I think that happens is because there's if you will, a changing of the guard in the gut microbiome, right? So we know that peristaltic activity and all that is influenced by the microbes that are in the gut. And when you've got the Megaspore going in and making significant changes to the gut microbiome, those changes can be represented as constipation. So I would say increase water. In many cases, you can push through it and punch through it, actually go to the higher dose faster. And if those two things don't work, then as was suggested, you could start with the HU58 first. That almost never has a constipation-like effect in people.
Okay, great clinical pearl there. Anne's asking, sounds like it would be beneficial to take Megaspore Biotic during intermittent fasting or extended multiple day fasting. Any data on that?
So we normally recommend to take it with food because the spores become active in the presence of certain amino acids. And of course, they help you break down and digest your food as well. Now, I intermittent fast every single day. I normally do a 16, 17-hour fast every single day. I take my megaspore usually with my first meal. So I would recommend if you're intermittent fasting, you take it with your first meal, and then that allows the spores to come active and colonize and do all the things that they do in the gut. If you're doing a multi-day fast, if you're doing any sort of minerals with it, with the multi-day fast, then I would take the spores with that, with those minerals and all that. Oftentimes it could be enough of an amino acid or something in there to activate the spores, but normally with food is best.
Okay. Laura's asking, would parasites increase IL-6?
Parasites can to a certain degree, but the research is not indicative that parasites are a key driver of IL-6 at all, because parasites will often increase IL-17 and Th17, right? So they induce more of a hypersensitivity response, which is like a mast cell, IgE, IL-17 response. So parasites are likely not a key component of increasing IL-6. It's almost always intestinal permeability and a dysfunctional gut microbiome with low diversity and low levels of bifidobacteria and Faecalibacter prosnitzi. There was a big study called the Boston-Dublin study that was done during the pandemic in collaboration with a university in Boston and also with the research institute in Dublin, where they were screening thousands of people who ended up with COVID, and they were looking for biomarkers that were predictive of whether these individuals would have really severe response to the disease and need hospitalization, or they had very mild response to the disease. What they basically found was that people with elevated IL-6 had a much higher risk of having a very severe response, hospitalization, even mortality with COVID than people with reduced IL-6. And in correlation to that, they also found that people with reduced bifidobacteria and Faecalibacter prosnitzi had a much worse go at the condition than people that had adequate levels of those organisms. So it's all tied together, the reduced bifidobacterium, reduced diversity, reduced Faecalibacter prosnitzi, all of those things increase IL-6 and then makes you more susceptible to all these conditions.
Makes a lot of sense. Just a couple more questions here. What do you think of peptide therapy for gut dysfunction not responding to normal protocols?
I think peptides are incredibly promising. I think it's a fascinating area of science. The problem with it, though, is that everything we know about the gut microbiome says that it's the microbes that control the space, right? Whether you're fixing the lining of the gut, whether you're fixing the mucosa, whether you're fixing the tight junctions or the immunological response, all of those factors are dependent on which microbes are present and at what levels. And so ultimately, you have to address the dysbiosis and the microbes because they are the mechanics of the gut. So peptides, I think, can take you to a certain level. I think, for example, like L-glutamine is a good example of something that it's a nutrient that a lot of people will use to try to help the gut, but it has marginal benefit because it's just a nutrient. And if you're still dysbiotic and you still have those microbes that eat away at the mucin 2 layer and not rebuild the mucin 2 layer, you're still going to end up with leakiness in the gut because you haven't fixed a core problem, which is the microbes themselves, right? So that's the key to fixing the gut, is you have to address and find a way to change the microbes.
That makes so much sense. And I have to say, I just love your super simple and description and explanation of that dysbiotic gut, of those that are breaking down versus building up that mucin 2 layer. That's brilliant.
Thank you.
I'm super sensitive to time. We've gone quite over. I can see the questions keep coming in. Kiran, do you have time for a couple more quick ones here, or do you?
Yeah, absolutely.
Okay. So we have one here from Cindy. There's some discussion here that Kiran has answered regarding that bifido strain in a simpler formula. So a question here about saffron. Saffron has great research for effectiveness in depression and anxiety. is it still effective in the presence of inflammation that's shunting tryptophan down the kinase pathway?
Yeah, so it's not as effective in that case, right? So, and that's why it pairs well with the 1714, because in fact, the 1714 will improve the efficacy of the saffron itself, and the saffron will improve. And once you've shunted back the tryptophan metabolism to serotonin and melatonin, you're going to get a much more bang for your buck out of the saffron. And that's why they pair well together, because that helps drive the mechanism to improve the chemistry in the brain. But the underlying cause is that tryptophan shunt, and the tryptophan shunt is addressed by the 1714, among other things. Of course, the brainwave changes and all that are also really helpful from ZenBiome. So, note this is really interesting. I work a lot with some of the top researchers in the world that are studying COVID long hauler syndrome. And I was just in Ireland a couple of weeks ago meeting with them. They're at the APC and there's work we're doing together. And basically what they're discovering is that the key mechanism that is happening in people with COVID long haulers is they have a long-term shifting of tryptophan metabolism. They all are producing quinolinic acid instead of serotonin and melatonin. That's why the vast majority of COVID long haulers are neurological symptoms. And if you can shift it back, if you can shift the tryptophan metabolism back, you can really help these patients. So we're using the 1714 in COVID long haulers as well.
Fascinating. Can eczema be a symptom of LPS overload?
Did you say eczema?
Eczema, yes.
Yeah, absolutely. So skin-related symptoms, eczema, acne, psoriasis. We know acne, there's good studies showing LPS overload drives acne lesion formation. In fact, we have a probiotic. We have the largest probiotic acne study ever done. It's a spore-based probiotic, very similar to Megaspore, but slightly higher doses of some strains, called Serene Skin. In our study that we did, the second study, so we have two studies. The second study, we showed a 70% reduction in acne lesions in 90 days with the probiotic, and that's largely because of two things. One is we're reducing LPS, and LPS is a big driver of inflammation in the skin. And then number two, we are also changing short chain fatty acid production. We're over time increasing acetate production, and acetate has a very strong anti-inflammatory effect on the skin and areas peripheral to the gut. So yeah, absolutely. LPS is responsible there as well.
Wonderful. Okay, and this will be our last question from Darlene. When one has a very high Firmicutes level, would you still have that person take Megaspore, or would you have them take one or both of the ZenBiome products because of the bifidobacterium?
You would absolutely still want to take Megaspore, because elevated Firmicutes is going to be associated with higher risk for leakiness in the gut. Right. So we know that from the studies on obesity and metabolic syndrome with Firmicutes elevation. So these individuals are likely have a higher propensity for leakiness in the gut, driven by dysbiosis. And so you absolutely have to address the LPS. And in fact, Megaspore by itself, and we've published studies on this, dramatically increases Bifidobacteria, Lactobacilli, Fecalum bacteria, and Akkermansia in the gut microbiome. Mm-hmm. So they increase many of the Bacteroidetes microbes in the microbiome, thereby helping and rebalancing that Firmicutes Bacteroidetes balance in the system.
This has been fantastic. Thank you so much, Kiran. How can folks stay connected with you? Obviously, we're all, active users of the Microbiome Labs products, but in terms of you personally, your teaching, your speaking schedule, all that kind of good stuff, how do we stay connected?
Yeah, so please reach out to me on Instagram. My Instagram handle is Kiran Biome. I post a lot of my talks and interviews and presentations at conferences and all that there. And then also come to our website at microbiomelabs.com. There's a events component where it posts a lot of the areas and all we're speaking. I'm doing a lot of private events this year, which is one of the key things I want to do because I want to be out in the market working and talking directly to clinicians as much as I can, especially with some of the new exciting research that we have coming out. So we'll be posting where our private events are happening, and we've hit almost every state in the last 18 months. So we'll keep making our rounds, and I want to stay connected to the clinician database. So Instagram, microbiomelabs.com. Between those two, you'll find out a lot about what I'm doing.
Wonderful. Well, thank you so much. This has been brilliant. I don't have the date of the next one right on the top of my head, so I will send all that to you via email. I also saw Karen in here chatting. People were asking about new protocols and things, so I will make sure that we send that out to all of you, whether you're here live with us or watching the recording. I'll make sure you get all of those resources.
Thank you so much. Thanks for having me. Really appreciate it.